That's okay. Oh, no. Hey, kids. Smath here. I got the sharing set up. Boom. Hey, come on now. Here we go. There we go. So I've got another KSP kind of problem for you. I know we did the other two. So this is KSP and common ion. So what we're going to do is we're going to work with SRF2. So let's just treat this like example 1. And what we're going to do is calculate the solubility of SRF2. Now, from the last one, we remember that solubility, this value of X, which could also be equal to S, is going to be equal to our concentration, sort of. We just want to be careful with this one. So let's, we got to be given one more piece of data here, and we are told that the KSP of this is 7.9. Well, that's pretty big, times 10 to the negative 10th. That seems like a very small number, but in terms of KSPs, that's really pretty big. So now we're just going to go with our equation. Be sure to write the dissociation SRF2 just so that we don't miss anything. That's going to turn into SR2 plus 2F minuses, because now we want to make sure we see this is going to be X, this is going to be 2X, so that my KSP is going to be X times 2X squared. Remember, 2X squared is not 2X squared. So this is 7.9, 10 to the minus 10th. And for the most part, you guys are probably going to end solve this, but you could just divide by 4 and take the cubed root of it as well. 7.9, 10 to the minus 10th. And this will give us an X, or a solubility of 5.8 times 10 to the negative 4th. And that would be equal to our concentration of SR. That would be true. And if we said, hey, by the way, what's the concentration of F minus? Well, the F minus, remember, was 2X. And so in that case, just take your 5.8, double it up, and you get 11.6, 1.6 times 10 to the minus third would be equal to our concentration of F minus. It didn't really ask us for those, but we're going to give them to them anyway. You'll kind of see why. So that takes care of the KSP part of this. Just what's the solubility? And that's not a big deal. But here's the part that is now, and that's coming up in example 2, where we say, let's calc the solubility of the same stuff, the SRF2, in 0.1 molar, whoops, excuse me, that's SrNO32. And this is where the common ion comes into effect. Because now, if we write out the equation, SRF2 is going to go to SR2 plus 2F minus. Now, all of a sudden, we're going to start out with 0.1. And this is still going to be 2X. That's what the common ion does. Remember, common ion is, we have SR, which is a common ion between SrNO32 and SrF2. So it's common. What it's going to do is repress or depress the ability of the SrF2 to dissolve. So now what do we get? We get the Ksp here is equal to 0.100 times 2x, and don't forget to square that again. That's going to be 79 10 to the negative 10th. And now what we find out is X, or the solubility as we call it, is going to be 4.4 times 10 to the negative 5th. Okay, so our solubility went down a wee bit. We didn't add very much, but just a wee bit. Now, someone out there is probably saying, well, shouldn't it be, shouldn't the concentration of SR2 plus be equal to 0.1 plus X? Yeah, it should be. We could do that. 0.1 plus 4.4 times 10 to the minus 5th. Guess what? It's not going to change sig fig wise. We're already at -3. It would be equal to, and I'm just doing this to be facetious, 1, 2, 3, 4, 5. It would be equal to that. Guess what? That's not worth it. So we're not going to go there. So that's example 2, where we had our SR was our common ion. Now, what would happen if our F was our common ion? This is the last scenario. The first one is calculate everything freely. The second one is calculate it with SrF2. And the third one's going to be calculate it with F2 being the common ion. So here we go. And this is example 3. Calc our solubility in 0.4 molar NaF. And so now we have our SrF2 breaking apart, same thing, SR2 plus 2F minus, but in this case now, we have 0.4 is our concentration of F minus, not 0.8. We're not going to double it because remember, we're doubling it because it came from the SrF2. But if it doesn't come from the SrF2, it's just the amount of F in the solution. And in this case, excuse me, it came from NaF. So we have that 0.4 and we have X. So we have Ksp is equal to X times 0.4. Now we do have to square it. That's an equilibrium square. And now we have 7, 9, 10 to the minus 10th. X, which is equal to our solubility now, has gone down to 4.9, 10 to the minus 9th. In true fashion, we did suppress that the molarity of the concentration of S was repressed or decreased by having a common ion in place. I'm Smath. This is a common ion video, and I hope this helped you. Thanks so much.